the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Good evening, everyone. Okay, this is in the center of the screen. It's better now, but you can see part of a microphone, but yeah, let's leave it. Perfect, I can even hear myself, so I guess everything works, and we can get going. Today's moderator is KrzaQ. KrzaQ, thank you for being here. If anyone has any questions during the live stream, please be sure to tag KrzaQ either on YouTube or on IRC. That way he will be able to let me know, which isn't really true because I didn't open our secret portal that allows me to actually see the questions, which I'm doing right now. Okay, so today's stream is going to be about CHIP-8 again, and it's going to be the third episode actually, and what we have left is basically all the features, because I guess the core is implemented and now we have to like catch all the features which are around the core, which are basically a couple of instructions which are relying on the call stack, which is not existing yet. Then I believe there is like, we need to provide a font. I need to check it out later, but initially I will not provide a font. We need to create timers, that being said. We need to create keyboard support, which is going to be interesting. I'm probably going to do like 2 types of keyboard support. For example, I'm going to also support arrow keys, which are normally not supported. But yeah. So I guess we can get going. By the way, all the source code is obviously available on my GitHub. Yeah. Perfect. So let me find the... Okay, here we go. This is, I think, the latest source code. Oh, and I did not set the font. My apologies. Here we go. As you can see, I'm using Sublime. I'm getting used to it. Still, the color theme isn't there, as you can see. Our code has somewhat grown. It's like 500 lines now. And just for if you have not been here on the previous streams, CHIP-8 is a really simple virtual machine. Yeah, I guess I also need to change the font of this. And it was like created ages ago, and I'm trying to implement it using SDL and C++, so that it, well, is basically an introduction to copy-paste problem. Okay, so it's basically an introduction to virtual machines, And it's quite important that you understand virtual machines if you want to, for example, play with JIT, or what is more interesting for the next streams I have planned is actually playing with anti-RF virtual machines and how to analyze them. You have to well know how a virtual machine works in order to analyze it. But we'll get there eventually, not on this stream, maybe on the next one, or depending on how much time will it actually take to finish the implementation. Okay, so this works. Let's try to compile it. I even have a make file. I have also a lot of warnings for unused parameters, but that doesn't matter. And do I have make test? I do not have make test, but I do have CHIP-8, so let's do CHIP-8 as an executable. Okay, and it says it needs something, so I will give it yeah, pong.rom. Pong.rom isn't an application I've written, it's actually something I've downloaded off the internet. So yeah, this is the current state. As you can see, there is nothing to see yet. So what we did previously, I basically the whole episode implemented various opcodes, right? And I guess I should also fetch a Wikipedia page with the opcodes. So to do that, I do need to spawn a browser. Wiki CHIP-8, perfect. And there aren't too many instructions, like I don't know, 30. Oh, by the way, there will be a mission today, and Mormus CTF is going to stream after my stream, basically. So, two good news, I guess. Cool. So I do not have all the opcodes implemented. Which opcodes am I missing? I am missing, I believe, the first three ones, which are well, no, clears the screen I actually do have, then returns from a subroutine. I do not have this one because I do not have the stack yet. CHIP-8 is a pretty weird machine which has a separate stack which isn't in the memory. It's actually like a separate RAM part which is dedicated only to be the call stack. So I guess I'm going to start with that. There's returns, there's also calls. I do not understand what this is yet, but there is, yeah. I'm going to implement first this and create actually a call stack. Obviously the stack is going to be 16-bit, and what am I going to use to actually implement the stack? I guess I'm going to go with like a standard list, because why not? Like a C++ list. And should it be public? No, it shouldn't be public. I believe it should be here. So std list and uint16t, because that's the type I want actually. And call stack. Okay, and now I just need to implement it. I also don't know, because the problem is with Wikipedia that the description here isn't really verbose, as in what should happen in edge cases. And edge cases is what's funny, right? So in this case, for example, what should happen when we do a return and the stack is empty? It's not written here, it's perhaps written somewhere else. And I guess I'm going to look for some more detailed specification. As you might remember from the last time, there were some other instructions which I implemented and which I was basically guessing what is the correct behavior for the given instruction on some edge cases. And yeah, and I wasn't sure if my implementation is correct. I guess we will see when I will try to run software, like a lot of software, to test the compatibility once I implement it. Okay, but so I do have this. I guess I'm going to close. How do I close this? View, sidebar, hide open files. Perfect. That being said, view, layout, 2 columns. Okay, and I guess can I open the same thing into... I don't know. Can I? Yes, I can. Does it actually synchronize? No, it doesn't synchronize. This is something I really liked in Vim, but it would synchronize. So in that case, I'm going to change the layout again. Sorry, it's just me learning a new editor. So yeah, I know that we have a call stack. So we go and start implementing it. First instruction is, I will start with this one, 2NNN. Okay, so, okay, the opcode is obviously where we want to jump, but that isn't the important part. The important part is the current PC, and this is something I have to put on the call stack. So I'm going to do call stack and then push back, push front. C++ list. I need to see what methods are available. Is there a C++ stack, by the way? Okay, there is a pop front also. Yeah, it doesn't matter. I'm going to just push back. The current PC, the current place where the instruction pointer is, then I do the jump. So then I do PC equals arg nn opcode. Sorry, that's not how you write it. Here it is. And I think that's it. What I could do here, maybe, I'm going to add it as a to-do. Perhaps add a call stack limit. Because what would happen if I would just have, you know, a recursive amount of calls? Currently, it will crash my virtual machine, which isn't something which is desired. A better way to do it would probably be to, I don't know, just crash the application which is inside the virtual machine. I'm not going to worry about it, I'm just going to note it as a to-do. Even if it crashes, it's not really that important. Or would it? No, it's not important. It would throw an out of memory error, and that isn't really security relevant unless you define security as stability of operation, then that's a different thing. Okay, KrzaQ says something, but there is a question? Oh, there is a question. KrzaQ actually says that there is a real stack. Perfect, let's take a look. Okay, and how does this? Oh, there's... Okay, I'm going to use the stack then. I don't think there's like a huge implementation difference between a stack and a list. So I don't think that really matters a lot, but probably stack is like... Maybe the pop operation actually, apart from removing, actually returns the value. No, it doesn't return. I do have to use the top, I guess, yeah, to access. This is quite weird. What I find weird in C++ is why is both on list and in the stack container, why is pop actually not returning the value it's popping? Maybe there is a good reason, but it's not returning any elements, so I don't know. I just like it. Okay, so stack is. Going back to my implementation, which was somewhere here. Again, I'm not doing here anything, I'm just going to change this. And now this was the return. Was it the return? Or am I mistaking? I am mistaking, aren't I? Yes, it was. No. OOEE. OOEE. What's EE? Oh no, EE is nothing. Again, I made the same mistake assuming these are actually letters. These are obviously digits, hexadecimal digits. So yeah, I guess we do call. And I'm making a mistake here, but I'm kind of making it on purpose. I will fix it in a second. Call stack pop. Okay, this should be fine now. Now the mistake here is like, what if the call stack is actually empty? What will happen then? What does top return in case the call stack is empty? Since it's supposed to return a reference, returns reference, this is blah blah blah, will be removed on the code. Okay. So, I don't know. I'm quite curious what happens if I actually try to pop something. Oh, sorry, to access the top element if there is no top element. My guess it's either going to throw an exception or probably return the default value for the type, which is 0. Okay, so I guess I should also check whether there is something. Is there a size here, like dot size? There is no size, come on, no, there is, yeah. So if it's empty, if the call stack is empty, then, and this is a good question, what do I do then? Is there something that should happen in that case? So stack, let's look at the stack. The stack is used as a routine, blah blah blah. Okay, at least 16 levels. And that's about it. Oh wait. There's actually like a region where I guess it's expected for there to be the stack, and I actually created a stack not in RAM. I don't know if that matters too much. Let's assume it doesn't matter. Maybe I will just add a to-do here, like in case this fails, just use OXEAO area for the stack. Okay. Let's do it this way. It might fail if some application is doing funky stuff like actually changing the return value. So what do I do here? What do I do if the call stack is actually empty? I'm going to like figure out this later. And for now, I guess I'm not going to change the PC at all, so I'm going just to return from here. Opcode is unused here, so I'm going to comment out the name. And I guess that means that 2 more things are actually implemented. I am going to close this and I'm going to check. So what's this? Seriously. Calls RCA program at address, not necessary for most ROM. Complementaries. What is this? Alright, I have no idea what is this. For now, I guess I'm going to assume this is exactly the same thing as called subroutine. If this backfires, I'm going to then try to figure out what is it. Or maybe no, I'm even going to do a different thing. I'm just going to not implement it at all. And I'm going to do write some stuff here. Like not implemented, but used. And if this ever happens, then I'm going to try to figure out what's the reason it's actually happening, and I'm going to again comment out the argument name, which will basically, well, the compiler will not complain about but there's an unused parameter. So perfect, this is now done. Now what I'm missing are the timers and also fetching the keyboard. So I have this. Sets Vx to the value of delay timer. Okay. Okay, I guess it's time to actually implement both the timers and the keyboard, because without it I don't think anything is going to work. So the timers are rather easy. They are both counting down from some value until they reach 0, and when 0 is reached, I have no idea what's happening. But that hardly matters. Do I have already the timers? No, there were no fields related to the timers. I guess I'm going to put them here because most of the variables are public, so why shouldn't the timers be public as well? So the timers are counting from until they reach 0. What's the maximum value of the timer? I guess it's going to be 8-bit, maybe 12-bit, maybe 16-bit. Oh, sets the timer and from the VX. Well, given that the VX is only 8-bit, so I should assume that the timer is also 8-bit, I guess. That being said, let me look maybe for the delay timer. No, this is, I guess, the only place this is actually set. Yeah, at least on Wikipedia there is no more information. Obviously this is not the best specification, but it should be good enough for our purposes, unless we actually get into, you know, debugging, then I'm going to probably need to look into it deeper. So okay, so the timers are 8-bit counters. So we have a delay timer, which I'm going to initialize to 0, and we also have, sorry, this is again 8-bit, a sound timer. Timer, which I'm also going to initialize to 0. I am not going to do any sound effects yet. I'm going to probably just handle the timers normally. And now I need to actually decrement them with this frequency. That means that every 1/60th of a second, I need to do like some timer, or actually both timer -1, if they are not already 0. If they are 0, then I should stop at 0 and actually not decrement it. Therefore, where is a good place to do it? So it's probably... I could do it in two places. First place is actually in the main thread, right? So around here, because, well, I am constantly going through this loop anyway. This loop is non-blocking. It is constantly going and running. It's a busy loop. So I could do it here. I could check the time, check whether the appropriate number of milliseconds have passed, so 1/60th of a second, and then decrement the timer. What I could also do is I could... I think that would be the best way to do it. The second way to do it is actually to do it in the main loop of CHIP-8 itself, assuming that, well, I mean, the value changes only between instructions. What I would have to take into account in both cases is what happens to the timers in case the, like, I don't know, I have a system lag or some instruction. For example, there are blocking instructions, right? So the blocking instruction get keyboard. This one is blocking. A key press is awaited. And it waits constantly for a key press, and then after, I don't know, 2 seconds, the key press arrives. So what should happen to the timer then? Should the timer be decremented only once? Or should it be decremented actually like 120 times or like 60 times? I guess I should take this into account in both places, regardless of where I implement it, because the same could happen if I have again, a system lag, like for example, I don't know, I'm alt-tabbing or some other process suddenly starts to eating my CPUs, and then this process would start lagging, and the loop iterations would actually be slower than 1/60th of a second. So I need to take both of this into account. So I guess what I'm going to do is I'm going to do it here. I'm going to assume in the main loop that I actually I'm going to assume in the main loop of which is the second thread, the virtual machine thread, I'm going to decrement the timers, calculating how much they should be decremented, obviously. And this way I don't have to do any thread synchronization, which is, I guess it simplifies the code a little. Now, how do I get actually the time value? But there's something like SDL get tick count or get ticks, I think, yeah. It should return the time in milliseconds. Regardless whether it says ticks, I think it should be in milliseconds, yeah. So speaking of timers, timers are a really interesting part of computer architectures, because like, where does the computer get the time from? Where does it get the ticks from, right? And there are actually a couple of places where the computer can get the ticks from. I probably did mention it already, but on some other streams, but it's like this. There's a PIT, which is like a programmable interval timer on your motherboard, or actually like, I think it's either in the PCU itself or one of the chipsets near the PCU, like Northbridge, Southbridge, platform control, blah, 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 controller, blah, blah, blah. Anyway, that gives you the time with frequency 1/64,000th of a second, so basically 65 kilohertz. Then there is a high precision interval timer or event timer, which is like way faster than that. Then there is the real-time clock, which is basically where your BIOS takes the time from. And there's also like the CPU itself has, you know, cycles, right? And that could be used to get the time from as well. But that's only part of the story. The second part of the story is what's actually the resolution of the time you get. I mean, for example, this function, right? It does return the number of milliseconds, but is it updated? The time counter of milliseconds, is it updated every millisecond? Maybe it's updated every 10 milliseconds. So I don't know that actually. So again, the resolution of the timer and actually how frequently is it updated, these are two different things. If you go to my blog, to the /n where I keep my notes, there is something related to, yeah, resolution and update intervals of timers, and there is a nice table I made some time ago. I don't know if I have, oh, I do have the old SDL get ticks part here, which I guess it says that the unit is 1 millisecond and it's updated every millisecond, so this basically works for us. But if you look at some different functions, like for example clock in on Linux, right? It's basically updated every 10 milliseconds, even though it claims to have an even higher precision, if I remember correctly, than milliseconds. So yeah, it's basically good to know your timers. In our case, this works perfectly. I mean, everything which has a resolution or actually is updated more frequently, or at least 60 Hertz, that works fine for us. Therefore, here, what's the unit? Okay, it's unit 32T, and I don't know, I'm going to call it last ticks. Now the absolute value of it doesn't matter. I think it's probably a timer from the, oh, it says that it's from the moment where the library was initialized. It doesn't matter for us, we only care about the absolute, sorry, the relative value between two measurements, so the distance between two measurements of time. Okay, so here I'm going to grab the new time, so I'm going to call it now, and I'm going to grab it. Now what I'm going to do is I'm going to make it, there are two ways to do it. One way you have to do some math and the other you don't. I'm going to do it the way where you do have to do some math. I'm going to check whether between the last ticks and now, which I should actually do this, whether more time than 60 milliseconds did, sorry, it's not 60 milliseconds, how much is it anyway? It's 1/60th of a second, which means it's give or take this many, no, actually this many milliseconds. So 16 milliseconds is the amount I'm going to use. It's not super precise, it will have some errors. I think that's going to be, we're going to be fine. Okay, so what did happen? Some weird scrolling. Yeah. So if it's more than 16, because again the unit here is milliseconds, that means I actually do have to update the timers. Therefore, I need to check by how much do I have to update the timers. So I'm going to do obviously this is a typo. Let's call it diff, and diff is actually going to be this. And by how much is how to call it? Units, no, maybe ticks. Ticks as in VM ticks or timer ticks, let's call it. It's actually diff divided by 16, right? Because I'm assuming it's 16 milliseconds. So this should tell me if it's only one timer tick, or if it's due to a system lag or some other thing, whether this more ticks did pass. And now what I do basically this, that each timer, starting with the delay timer, delay timer, is going to be equal std_min. Do I have actually, where is std_min? Is it an algorithm? It's, yeah, an algorithm. I don't believe I have algorithm included, so I do have to do it. Let's try to keep it somewhat sane and actually move it here. I do not have it. Normally I would have this like in alphabetic order, but starting with C libraries, then C++ libraries. It's obviously not. Yeah, whatever. Okay, so I'm going to pick the minimum value of either 0 or, and I'm actually going to cast it into an integer here. Delay timer minus timer ticks. And the sound with sound time, the same, sorry, with sound timer. So let's see if this actually makes sense. So let's assume that the delay timer is at 0 already, right? So it's 0. And then I have like the timer ticks equal to, I have this equal to, I don't know, let's say 3. So we haven't updated in the last 50 milliseconds, right? So that's like about 48 actually milliseconds. Okay, so in that case, I have 0 minus, and this is all converted into integers. So it's 0 minus 3, which is minus 3, and I'm taking minimum, so no, should I take maximum of it? I should take maximum of it, right? Yeah, it's good that I actually took it out. So having this, now I have either 0 or minus 3, I take 0. Well, if this would be actually larger than 0, it would be like, I don't know, 56, because the delay timer would be larger, would be 59, for example, at the beginning, then I would take this, so this is fine. Yeah, it should be max here, so my mistake, but thankfully found at this point. So do I need, there's a question, do I need to do any casts here? I do not need to do them here, because I already have so both these types are already in 32, right, as you can see here. And then I do the subtraction, but since the time is always progressing forward, and there's a catch here, but I will get to it, but since the time is always progressing forward, then, well, I will assume that now is later than the last time I actually took the time. Because I could have taken the time, I don't know, like 10 milliseconds ago, and now I'm doing another measurement. So therefore now will always be larger than last ticks. And thanks to it, this value will be always positive or 0, and then I have this 32-bit value. Because this diff even can be 32 bits, it's probably going to be way smaller than 32-bit limit, but yeah. And then I actually like, well, this is, you know, shift right by 4 bits, so it takes now 28 bits, so I can convert it into an integer without having to worry about whether it fits into an integer. So I think my types and math here are correct, and the catch which I did mention is basically, can I assume that time is always moving forward? Now, what are the cases where the time is not moving forward? First of all, well, here we are lucky enough that we have actually ticks, and I kinda trust the SDL library that these are actually the ticks of the CPU or whatever timer, so the ticks are always incremented. If this would be real-time clock, or this would be based on the real-time clock, then it gets funny. And why does it get funny? It gets funny because, first of all, what happens if we, I don't know, synchronize with the time server, and the time server actually has a time which is 1 second before our time. So we've suddenly, the last ticks was taken at, I don't know, like something 38, and we synchronize the time, and suddenly we have the end of the time like 57. So I suddenly get a really huge value in this part, because I get a negative value and then it actually becomes an unsigned, and the unsigned negative values are really huge. And then it gets really funny. And especially this part would get even funnier, because I have an integer overflow where nothing would break apart from, I don't know, maybe the ball of, or some sound doing some weird stuff which it shouldn't, the ball in a ping pong, on a like pong game, right? Like moving really fast suddenly for a couple of seconds. This is probably the only problem we have. We might experience some, again, assuming that getTicks is actually based on the real time, and I don't think it is, but assuming, we might also have a problem with, you know, the leap second, for example. In leap seconds, it also might jump ±1. If you don't know what leap second is, it's quite funny. Because you know what's a leap year when we suddenly in a year have one more day? Well, there's also something called a leap second. And to make things... No, it's thankfully... I was going to say that if I remember correctly, we sometimes do have to subtract 1 second, but no, thankfully it's always either 0 or we add 1 second on a specific date. 1 second. So yeah, it's somewhat, I guess, important if you are really have to have a precise time, right? Like Earth time or Sun time, I guess. So I think this math is actually correct. What I do need to do now is I need to do this, which is basically like, since we did the decrementation now, we need to store the current time, which is incorrect because we need to do something more. We actually need to do this. And this isn't correct either, or is it correct? So the problem here is that, like this. But we have the time, right? And the time is going. This is the this was the last measurement we took, and then we have some. The time is going, and we have now, which is here, for example, right? Now, okay. And now let's assume that this was the first 16 second, this was the second 16 second, third 16 second, and the fourth 16 second. Now, the question is, what happens to this area, right? Because if I would make now my last, then that would actually mean that I'm losing this area. And I shouldn't lose it. So I actually should figure out how many milliseconds am I losing, and actually subtract it from now, which would basically like rewind now here to this point. Yeah, I'm running out of colors, to this point. And having now rewinded here, we can put it into the last, and that would work. So is my math correct? Should I do the way I did? I'm assuming, like, for example, this is 3 milliseconds to match. So if I do modulo, yeah, but that should be fine. This math should be okay. Take into account, that's not the way you write account, unused, used time. Yeah. And this should be fine now, so this is actually, I don't know, handle timers. So the timers work now, apart from actually implementing the opcodes to set them and get them. Oh hey, Mormos. Bastian says that SDL get ticks will wrap around 49 days. That's correct. I think it's the same actually to get tick count in Windows. So there's a time, if your application is running for too long, you have to take into account that the internal counter of the timer might overflow. And if it overflows, well, you're dealing with the standard problems of an overflow. You might have to detect it. And I guess it's also important for the math which I did here, right? But for us, I'm not going to care about it because nobody is going to run this emulator for 49 days straight, right? At least that's what I hope. Okay, perfect. So, timers. Timer. Okay, 2 timers. Let's start with FX07. Where is FX07? It's here. So X, what's X? Is the number of registers, so let's get it. Do I need to get it? No, I just need to do registers arg X of opcode has to be now from now equal to the timer, the delay timer. Is it the delay timer? Yes, it's the delay timer. Dev no delay timer. And that's it. That's actually just fetching the value, the current value of the timer. And then I do have setting, which is fx15 and fx18. So we have to set, sorry, 15 is the delay timer. We have to set the delay timer to v arc x of opcode to whatever is the state of this register. Is this correct, what I've written? Yeah, I think it's correct, and the same with the sound one. Now I'm not adding real sound support. The sound support here is basically that if the sound timer is non-zero, you should beep, otherwise you should stop beeping. I'm not adding it now, mostly because I don't even have configured my sound card to be able to pass sound to you. So you wouldn't be able to hear it anyway. So let's leave it at the end. Okay, perfect. So this is already implemented. Now do I have to implement anything else? No, not for the timers. I do have to, obviously, the keyboard. The keyboard is the thing which is still not implemented, so I do have to implement this. Before I do it, I'm going to compile it and see if it actually, you know, still compiles, right? Are there any more warnings? No more warnings. I guess I should add some. I'm going to add some. Oh, it shows the centered position of the window. I am going to comment this out, and I'm going to change the so you can basically see to what should be the correct one. 2 is my top monitor plus, I don't know, 400. Let's see if this is fine. Okay, now you will be able to see it as soon as it spawns, actually. I'm going to, I guess, raise it a little, so it'll stay like this. Yeah, this is better because this camera is not obscuring it. Cool. So having this done, the keyboard is basically the last thing before I actually attach everything together and see if it works, and then start debugging, because it's not going to work, because that's how programming goes, right? So what kind of key operations do I have? Yes, I already did. I was wondering if I implemented the BCD, but I did. So there are 3 keyboard operators. One waits for the key press. Then we have, it's quite weird to actually see blocking operators in a CPU, but it's not so weird in virtual machines, so yeah. Okay, skips the next instruction. Whoa, that's pretty funny. If it's okay, so this is if the key is actually hold down or not hold down. And this is if the key is awaited now. Sorry. This awaits for any key press, I guess. Now the important part here is that, well, the keyboard of this device is funny. Where is the keyboard described again? Yeah, here we go. Input hex keyboard, which is only 16 keys. I actually thought there was a cool link to a picture of a hex keyboard. Is there? I'm kind of afraid to put anything on my live stream to this, but to Google Images, but let's do it. So I guess this is what a hex keyboard should look like. Or maybe like this. I'm not sure about the layout. Well, yeah. Well, whatever, that doesn't really matter to us too much, apart from what we remember from the specification from the first episode, is that the 8 key, which is on our normal keyboard numpad an arrow up, on this architecture is actually an arrow down, so it's inverted. Cool. How do I implement keyboard? SDL keyboard. Handling the keyboard event. So I always had a cool way to do it on SDL1, which was basically like have an array and just like an array of booleans and change a boolean to true or false, whether the key is pressed or not. Here I cannot do it because the key pressed are actually, but they changed it a little, and they're like 2 different things, I think, now. So hardly matters though, because we are not going to support the full keyboard anyway. So what I'm going to do, what you don't see off screen, is I'm actually going to find the file. Yeah, here we go. The file which has all the stuff related to keyboard events. There's something called the keysim. What's the keysim? And not here, so let's maybe do it here. Yeah. There is now the key code and the scan code. Now, what is what? I don't know. I never remember that. So the key code... Okay, so I guess it should be like this. One of these should be related to the keyboard. So on the keyboard, for example, you don't have lowercase letters. You only have uppercase letters. If you press a letter, you press an uppercase letter, and whenever you see on the screen that uppercase or a lowercase letter is displayed, that's because the operating system is obviously handling it. So the operating system might say, oh, in this context, in this application, when the focus is in this box, it actually should be a lowercase letter because the caps lock is turned off and you're not holding the shift key. That being said, still, if you look on the keyboard, there are only uppercase letters, right? So I believe the key code, in this case, what you see on the screen, is what you have on the keyboard. Now the scan code, in this case, should actually have both lowercase and uppercase letters, due to this being already the interpreted part, but it's not, so I have absolutely no idea what I'm talking about, it seems. Well, that doesn't matter too much anyway. Because again, what I do care for is I care about, I guess, these things like the numbers and the letters A, B, C, D. So I'm going to use any of these. Now about the events themselves, there's this keyboard event thing. Is there only one keyboard event, or are there multiple keyboard events? Like 3 events, for example. One event is keyboard pressed, second event is keyboard down, and third is keyboard up. So this is why I actually opened this event file, because I am going to... sorry, this is not... I'm going to try to find, yeah, this the SDL event union, which actually has all the events that SDL supports, and there's only one keyboard event that I can find here, which makes things, I don't know, easy or hard depending on how you look at it. Now, this is something I am going to totally not implement, or should I implement thread handling here? Sorry, thread synchronization. Let me check one more thing. Here. Okay, so it has to actually know which key got pressed. Huh. How do I do it in a somewhat sane way? Also, there's a good question, because like the key code is only 4 bits, right? It's from 0 to F. My question here would be like, what if the VX register actually has like OX1A? Does it mean that I should return true if A is pressed, or should I, well, actually skip the instruction if A is pressed? Or should I not return it because I should actually take into account the 4 bits which are not, which I don't know, should not be used, and then say that it's actually not equal? Well, I guess there is equal here. They don't do any ampersand operation, so I guess I should take this one into account as well if it's in the register. So this is what I'm going to do. Oh, there's a question. There are 2 questions. Why Sublime and not Vim? Well, I guess I did already talk about it a little. I'm sometimes trying out different editors, because I am looking for an editor which is both fast, as Vim was, and which supports like graphical widgets, which Vim does not. Because all the widgets, all the plugins you can write to Vim are basically text buffer based. And I think Sublime actually, you can do that. You can have like non-text buffer widgets, so I'm not sure about it, but yeah, so I'm trying it out, especially that I heard good things about it. How to write a program that supports different keyboard layout. So it actually doesn't matter for the program itself, it matters for the operating system. And this is also true for SDL. Well, for the program, you have to basically remember that if you're getting not a key press, but you're getting a basically already processed character code, which characters and keys are two different things, and one should be converted to the other depending on the context, obviously. So if you get some character event, then you have to remember that this is going to probably be Unicode or something else, and it will be more than 1 byte. This is true, like, I don't know, if you're writing, for example, Polish letters, right? Like, Polish letters are Unicode. This is not ASCII, so you have to take that into consideration when handling stuff. In the case of SDL, if we go to this, again, the events, there's something called like text input event, and this is where you can get the actual character which was typed. So, for example, in case of keyboard event, if I would press at the same time right Alt and A, which gives a Polish letter O, then which is A with like a ogonek, with like a tiny thing there at the bottom. Anyway, this would actually generate a keyboard event of right Alt and a keyboard event of A, but it would generate a text event of O. So when you remember not to mix it, then you don't have to worry about the keyboard layout, because that's something that the operating system is supposed to handle. You just have to remember that you can get non-ASCII stuff from the operating system. And you basically have to do all the processing on Unicode. You cannot do like you cannot use char basically. You have to use, instead of char, you have to use basically vuchrt or some other stuff. There are some nice guides how to write code for this kind of support that has like proper internationalization support. So I see people in the chat laughing about ogonek. It's actually the term that is used on Wikipedia. Polish letters, let's do it like this. Alphabet Polski, and let's jump to English. And yeah, it says ogonek on Wikipedia, so it must be true on English Wikipedia. Does this code work for the German keyboard or other keyboard layouts? Yes, it should work, especially that I do not care about like Z or Y. Again, I'm caring about the keys, I'm not caring about the characters which are being shown, so it should work. I can switch later the layout to, I don't know, Japanese or German, and we can see if it actually works, but for Japanese it might be quite funny due to, yeah, entering Japanese text is not trivial. I don't fully grasp it, but let's just implement it for now. So I need two things. First of all, I need a Boolean array of like which keys are actually pressed. So key. And again, I have only 16 keys, right? So I care about like from 0 to 9 and from A to F, and that's all I care about. So I'm going to use hexadecimal identifiers here. But apart from that, I also require for apologies for this part. I do require some other value and some form of synchronization between threads to let know the other part that some key has actually been pressed. Okay, pressed. Now, last key. Oh, maybe, I know, last key pressed. I guess I'm going to do this, and I'm going to do this here to initialize them. Okay. Question: why does the key combination Ctrl+C display the caret character and C in Bash? Let's open. That's a good question. So yeah, if I do this. So the reason is that basically the terminal sends to the terminal sends events, not really events, it sends characters to bash. And for some reason, the Unix TTY uses this for control, like a caret. So we are not seeing, I think, the full character. There should be like an escape sign here, like escape, then the caret, and then C, and that means control C. Like same with any other control, like if we do, I don't know, control F, or it doesn't display anything. But yeah, for control C, it's for some reason it's displayed in bash, but yeah, it's related again to the actual sequence of which the terminal is sending to the application, to bash in this case, which is running in the foreground and listening to the standard input. It's actually quite weird, because like most things you do with a window, like console window, and most keys you press, like for example, yeah, arrow up, arrow down, or like weird buttons like F9, F10, and so on, are escape sequences. That being said, if you resize a window, you actually send a signal to a process. So bash would, me doing this, sends a signal to the process. I guess you can like check it out quite easily by just tracing bash, which I guess we can do. No, that's the return value. Cannot attach sudo. Okay, and now I'm going to and nothing happens, probably because I forgot some option. Never mind. But you have to believe me, that is what really is happening there. Let's get back to the topic. I do need synchronization here, so I'm going to right here add thread sync. Now, one more thing is that last key press is actually, I should initialize it to -1. And I do believe we have a constructor somewhere, right? So I am going to, oh, actually on reset, I'm going to initialize it to -1. So let's find reset. Yeah, here we go. Timer initialization. Yeah, sounds good. Also, it's good that I had written this note in the past to remind my current self that I actually need this to do completed. Now, last key press, -1, which is going to mean no key is pressed at the current time or has been pressed, whatever. That's one thing. The other thing is that I'm actually going to, for key in, no, it's an array, I cannot do it in C++ still. For alright, so no key is currently pressed, which by the way might be false, right? I might be holding a key and resetting the virtual machine, so this might be false, but I'm going to risk it. Why not? Okay, this is fine. So now I need to go to the event loop and here add event handling. So if E equals, and again, what's the event type in this case? The type, yes, the type. The type is supposed to be equal to key down or key up. Key down where the key is obviously pressed, and key up where the key is released. Now the question is, if I'm holding a key, is SDL actually going to send keystrokes with the key down event with intervals? So why am I asking this question? Because like just notice what happens if I like hold some like the A key. I'm pushing it and suddenly a lot of letters appear, right? This is because the operating system is going to send the same repeated key press event with various intervals. Now the question is, apart from obviously key pressed and key released, so, well, sorry, key down and key up. So not to confuse key down with key pressed. So the question is, what will happen in this case? I'm just going to do like push ASDF to find out. So let's run it. And 4 to 2, sorry, 4, 4, 2. Key press, oh, obviously this is an array, so I cannot just assign to an array. This is not PHP. Okay, and now I'm going to hold the button A. Yeah, as you can see, I'm holding the button. I'm not tapping it, I'm holding it. And it does write quite a lot of ASDF, so this is quite funny. Do we care? I don't know if we care. We probably don't care. So yeah, this is something you should know, but I'm not going to care about it. Let's do it like this. Okay, and now I need the code of the button which was actually pressed. And I'm going to actually introduce a function to it. So int index, like, you know, index in the key pressed. In the key pressed array. So index is going to be, and I'm introducing a function here which is going to translate code to index. And it's going to return either -1 or the index in that array of like 16 booleans. How do I get the key? It's the key symbol, right? So this, so e key sim. I believe I do have to, yeah, use this. So there's another question, why did I switch from Vim to Sublime? Again, I'm experimenting. I like experimenting with different things. Vim is really cool, but being said, that doesn't mean there isn't anything better, right? I'm not saying Sublime is better than Vim, I'm saying I'm experimenting with it. Okay, malware analysis as the next topic. Probably no, because I wanted to like follow up the CHIP-8 stuff with anti-reverse engineering virtual machines and how to analyze them. Maybe later. I mean, I'm getting quite a lot of malware on my email, so yeah, we might be able to do it. And yeah, do ping KrzaQ if you have a question, because that way he actually can see that you have a question and let me know. Yeah. Perfect. So keysim and keysim, we did have it open here. Let's use, I don't know, scan code, key code, physical scan, physical key code, sounds fine. Or maybe no. Let's use the key code. I'm not sure if it matters actually. So I'm going to translate it here. Now, the key which was pressed might not be a key which I actually care about at all. So I'm going to do this. If this is not equal to -1, I'm going to actually use this. So what's the VM called? So VM is called this. Now key pressed IDX true. Yeah, as in VM object obviously. Okay, and I'm actually need to do like a similar code for. Yeah, so let's do like this actually, because the code for the key up event is actually like, it's the same, I guess. No, that's even better, they have a state here. So, yeah, if then in that case, if e key state is equal to pressed. This is actually, you know, a Boolean expression in C++, I think, or it will be cast into Boolean, which doesn't really matter for me. If the key is pressed, then this is going to be true, and if it's going to be true, then I will have true in my array of Booleans. Otherwise, well, if it's released, so it's not equal, then it's going to be false, and I will have false here, which is exactly what I want. Perfect. Now I just need to implement this function, which is supposed to return an integer, and it takes, what does it take? I'm sorry, a key code. I have no idea what that is. For all I know, it can be a class of some sort. Okay, there are two questions. You can use state and repeat to handle it. Ah, non-zero. Yeah, that is true. Thank you very much, Vesim, for pointing this out. Sorry for like, yeah, this is what Vesim is pointing it out, but there's this field which is like non-zero in case it's actually like the event has been sent due to, you know, the interval, which basically makes resending the event if the key is held down. Now, there's another question. The key pressed interval is changeable, right? Could you override the interval with a small value and cause a bug in some program that way? I remember at least one program crashing because I did hold a key for too long, so I guess that's possible. That being said, it's not your typical vector, let me put it this way. I'm not saying no, but it's not your typical vector. So again, I was using the key code, I believe. And again, I don't know what is this. Now, since SDL is actually C, this is not going to be an object, obviously. It's probably some enum. If I go here, what do I see? See these values. Well, okay. So, switch case. Switch. Key. And return -1 as the default. I'm not going to implement the default case. So case this, return 0. Yes, I do realize that doing a switch case is probably not the best way, but I could do some math and actually figure this out. I am going to let the compiler do the math, because I know that compilers optimize the switch case really well, so I will let them to handle the math. And these are not the only keys I am going to support, that's why these are not the only things I'm going to write here. Apart from that, I need this, the keypad. So, sorry, let's do it like this. And keypad has this. Okay. Oh wait, how was it again? Whoa, this is cool, I didn't know you could do it. There was some magical sequence which I already forgot. Oh. I don't remember the sequence. There was a magical sequence which would allow me to change multiple lines. I did it on the previous stream and I forgot it. Too bad. So let's do it the old-fashioned way. This is fine. Now I need A, B, C. Why does the keypad... Whoa, it actually supports keypad which has these... which actually has like A, B, C and so on via the hexadecimal characters, I guess. Okay, now is there... No, there's only, yeah. It's quite weird that like this is capital and this is lowercase, but whatever. Control D. I'm not sure what Control D does. C, D, E, F. Okay, and well, 10, 11, 12, 13, 14, 15. Perfect. Apart from that, I'm also going to support arrow keys. Arrow. Oh, it's just called it SDL down. And this is going to return an 8 because on this machine 8 is actually the equivalent of down. Equivalent? Is that how you say it? This is going to be 2 because that's up, and then left is going to be 4. I don't know. Is it 4? Yeah, I think it's 4 regardless. I can change it always later. And this is 6. So it's like up and down is inverted, not like the same way in case of a keypad. Okay, so this will translate it. So this should be fine. This should be fine. Now I need to implement the opcodes. And I still don't have thread synchronization, which is going to bite me probably. Well, probably no. I'm lying. In this case, it's going to be fine. Oh, one more thing. I didn't implement key press. So let's do it like this. If e key state is equal to SDA pressed, that means that VM last key pressed is actually index. Otherwise, if it's not pressed, should I do anything in this case? Yeah, probably yes. I'm probably going to just like... I'm probably going to use every opportunity to remove this flag. Or not every opportunity. Should I remove it here? No, I should... Yeah, I should remove it. If... that... So here's the problem. Because, you know, I'm thinking about edge cases, right? When you program, it's all about edge cases. Yeah, the easy stuff is easy. Now, what I'm thinking about is that we have this, which is waiting for a key press, right? And we have, and for example, we have one event. If we press a key, then I do mark last key press as the key which I did press, like with the index of a key. And obviously, if I let it go, then I'm no longer holding any keys. Therefore, I should change the last key press to -1 to indicate that I'm not holding any key. Now, what happens if I push one key, push another key, and let go of this one? Then that would reset like the last key to -1. But that's not true. I'm still holding this key, right? So edge cases. So how do I handle it properly? It's like this. For I, sorry, not this language. For I equals 0, I less than 16, I plus plus. And now, if now I need a flag, like all keys are released, equal to true. And if any key is being held, that was the word I was missing. It's not hold it, I guess. If this is pressed, then all keys are released is actually false, and I can break from this loop because I know already that not all keys are being released. So if all keys are released, then I can do this, otherwise I cannot, and this should probably handle this edge case. Now, there's the question. For an undergrad, is competitive programming a better choice to spend time on initially and then move to InfoSec, or jump straight to InfoSec basics? Do both. No, seriously. I mean, if you look at Yuru, for example, right? You know, Yuru, Vexili or like Adam Ivanik or so on, they did both. They are like both awesome in like algorithmics, competitive programming, and so on, and in InfoSec. So you can totally do both, and it's quite useful in InfoSec at some level to also be somewhat better in you know, in programming. So yeah, do both. And if you like would prefer to focus only on one thing and not do two things, then choose whichever you prefer to do. If you cannot choose, then like think about doing one, and if you like for some reason dislike the idea, then actually choose the other. Because in the end it doesn't matter really. After like, if you look at it in a perspective, after 5 years it will not matter which have you chosen the first as the first topic, because after 5 years you will know both. So yeah, just start doing stuff, basically. I'm not sure if that actually answers your question or the way you would like it to be answered, but yeah, that's my answer there. Okay, so I have this, I think, implemented kind of correctly. Now I do need to again implement these key ops. So first one is EX9E, where X is obviously the register. EX9E, it would be this one. What do we do? In case the key, so okay, this is where yeah, this is where it gets funny. So I'm going to do it like this. Index is equal to get X from the opcode if index is actually more than 10 or equal, or equal to 10, as in 10 hexadecimal, then when I know this is not equal, I already know, without even checking, I know this is not equal, skips the next instruction. This could be an interesting buffer overflow, by the way, like a read vector, but it could be. Skips the next instruction if the key stored in VX is pressed. Usually the next instruction. Okay, so if it's pressed, then... Yeah, but this is funny, right? How can I say if a key which does not exist is pressed, as in the key index is more than 16, where I cannot because the key does not exist? Well, on the other hand, you could say that, well, since, you know, it actually doesn't exist, then it cannot be pressed. So I'm going to go with that interpretation. So I'm going to assume here that it is actually pressed. So else, is it like this? Pressed, sorry, equals false. In this case, I'm going to assume that it's not pressed by repeating this, which doesn't make too much sense. So I guess I'm going to do this and remove the amount of code I need to write. Otherwise, pressed is actually equal to what was it? Key pressed from index. Oh, obviously this is incorrect, right? Because it's the... Yeah, this is correct. Okay, and now I know whether it's pressed or not. So if it's pressed, then skips the next instruction if it's pressed. So PC plus equals, not px, PC plus equals 2. And that's it. Now, this opcode is actually does the same thing, but goes the other way around. My apologies, which is if it's not pressed, I actually should get this in some separate function. I'm going to copy paste it. So if it's not pressed, then yeah. And again, there is this funky question of whether a key which does not exist can actually be unpressed or not pressed. I am assuming that it is always unpressed, therefore, yeah. It's quite weird though. But that's, again, like, when digging into a specification, look for the edge cases. The edge cases are actually what is important in writing decent code. That being said, the normal part is the part important when writing optimal code, and you have to do both. Welcome to programming and have a nice day. And this one. A key press is awaited, so this is blocking, right? Now the proper way to do it is to introduce a signal or an event, and I don't mean a Unix signal, I mean like more like a Win API event, which, how is it called in Python again, or was it just an event? Well, anyway, basically a flag which is synchronized between threads, and this thread would wait for the signal for the event to actually happen, and the other thread would actually signal the event. So this is the proper way to do it. Now, I am not going to do it in a proper way, because I know what I'm going to do will work. So while, and this is going to be kind of funny, key equals -1, while key equals last key pressed is not equal to -1, or is it equal to -1? No, it's not. While it's equal to -1, then SDL delay 1. Just like, this is going to be a busy loop, right? But I don't want it really to be a busy loop. I want it to give some time to the CPU. So I don't know, I'm going to tell it to rest 5 milliseconds. 5 milliseconds is enough to actually detach from the thread. Some other threads in the system will start running. And I guess in case of this architecture, having a 5 milliseconds in the worst case scenario delay when you press a key and before it reacts hardly matters. So yeah, 5 is an okay value. Obviously, when we are telling a thread to sleep for 5 milliseconds, that doesn't mean that it will sleep for 5 milliseconds. It might sleep, for example, for 6 milliseconds. It just tells the operating system, hey, don't wake up this thread before 5 milliseconds pass. And the operating system might just wake it up after 10 milliseconds. Yeah. Cool. Again, if you have any questions, ask this person, ask KrzaQ. Like ping him on YouTube or on IRC because, well, he actually passes the questions to me. I'm not looking at the chat, I'm trying to code. Well, I'm not looking sometimes. Cool, so, okay. And now I need to actually put it in the register. Now, there's a race condition here. I'm going to touch on it in a second. So, do I need to put it in the... Yes, I need to put it. So, argx opcode. And this is supposed to be equal to k, which is the last key pressed, which is the index. So this is fine. Now, what is the problem with this loop? The problem is lack of thread synchronization. And as you can see, I'm trying what I'm trying to do here, and keyword is trying. I'm trying to read the value of last key pressed into k and then see if k is actually -1. So now, what a compiler might decide to do in some circumstances, it might actually compare whether last key, reading the value again, is -1. So first read last key from the memory and put it in k, and then read last key from memory and compare it with -1. Now the compiler shouldn't do it due to optimization reasons and some other reasons, but it might do it. And in that case, we have a so-called race condition, because if we have, again, a time, right? We have, and the time is still going forward, and we do the first read here. So let's do the first read here, and we put it into the key, sorry, the k variable. And then time goes on, and, well, you know, it's like nanoseconds, but it still goes on. And suddenly a second read is going to happen, and it's going to do the comparison, this part, the yellow part. Yeah, so like last key equal -1. Now what happens if, like, between these two events, another thread, because we have a second thread running, actually changes this value? It might be quite funny, depending on like reading, writing order. It might not do anything. Worst case scenario, like absolutely worst case scenario, this register will be equal to 255, which might confuse the application. That being said, I don't think it's actually probable that this will happen. Oh, I see I have a donation. Thank you. Seriously, I wish the teachers at my university could explain stuff the way you do. Thank you for teaching, from VT. Thank you for the donation, VT. I do have to update the donation thing in the feed manually, so I will do it after the stream. We need to rewrite our, I guess, layout to handle super chat donations. Yeah. So currently, again, it's handled manually. Perfect. So I'm going to ignore this race condition here. I'm just going to note it that, like, to do Genveil, handle this race condition in a sane way. And this is not a sane way. It's even funnier because, like, I think modern compilers will handle it correctly, but it might actually, the compiler might assume that, hey, since this loop does not never update last key press, then I just fetch last key press somewhere here before the loop, and then never fetch it again. I might have to add like volatile before it, but I think it's going to work. If it's not going to work, yeah, look at this point, basically. There's a question, or actually a comment, in this part. Initialization doesn't make sense. Yeah, it's from Świnki3, he or she says that this doesn't make sense. I do fully agree that it doesn't. Let's remove it. Yeah. And in the end it does this. This is a blocking loop. Perfect. So I think we have everything implemented now, apart from sound, but that doesn't matter too much. So going to the main loop. Now we actually need to do the fun stuff, and the fun stuff is actually hooking up everything. I guess, so where's the fun stuff? Main loop here. So we handle the timers, and yeah, we don't allow the VM to run with full speed. We ask the operating system to actually delay it by 1 millisecond. It's probably going to be more than 1 millisecond, but we don't care too much. Execute the instruction. So to do it, we actually have to, I guess, decode the instruction. As you might remember, we have this array, right? But we don't actually have any function to decode the instruction, which doesn't matter too much. Sorry, it's a opcode table. So let's do it like this. First of all, I need to fetch from the memory big endian encoded word, which is the opcode. You know what I'm going to do? I'm going to actually have like, yeah, this is the same file, but since I cannot have the same file twice here, and so it would synchronize, I'm going to have it here. This doesn't synchronize, but it's read-only, so at least I'm not going to break anything. Therefore, okay, so first uint16t instruction is going to be equal to 0. Actually, opcode, let's go to opcode. Now, the PC, I need 2 bytes from the PC, so I guess I should do it like this. If PC is more than the amount of RAM is 4 kilobytes, so if PC plus 1 is more or equal to 4096, then I don't know, puts PC out of bound. This should throw an exception of some kind. However, I'm going to assume that actually did not happen. So, and this will probably flood like, yeah, I should do a return here. And I should actually do some more verbose stuff. I don't know if I had proper error handling, probably no. Proper logging of errors, so let's just do this. Okay, and it's going to be PC. So now we know it's out of bound, we return. And due to the return, I actually don't need this one. I don't like to have too many blocks. In Sublime File, View, New View into File from Fenrir. Thank you, Fenrir. I am going to use it for later. I'm not going to use it now since I already have this open, but thank you for telling me about this option. Okay, and now we actually need, now we are sure that PC is pointing to some address in the RAM, and it's some address which has at least 2 bytes, because we need 2 bytes. So opcode is going to be equal to, first of all, yeah, let's do it like this. First of all, sorry, what is the memory? How did I address the memory again? Just mem. Mem at PC. And mem at PC is going to be, because it's big endian, so I need to shift it left. And the second one, I don't need this OR here. I could like remove the initialization and do it this way. This works too, obviously. +1. Okay, so this is like big endian, which means most significant byte first in case of a 2-byte word. Now I have the opcode, and now I need to figure out which opcode is it, which function do I actually execute. Sorry, well, function, member function or method. And well, this is going to be somewhat slow and somewhat easy. So for what is it called? Opcode table entry. Oh, actually, like const author entry of opcode table. So for each entry in the opcode table, I'm going to check if the opcode and the entry dot, is it called mask? It should be called mask. How is it called? Sorry. mask, obviously it's called mask. However, it's equal to entry.opcode. And if it is equal, I have actually found the proper opcode, so I just need to do... Oh, one more thing. Actually, after doing this, I do have to increase the PC by 2, because I assume that PC, all in the code, I assume that PC is actually pointing to the next instruction. So this is quite important to do, otherwise some stuff might not work. Yeah, and I guess that's it, I just call it. So, handler it's called. So entry.handler is going to be called with the original opcode, because I do need the arguments from there. It does not return anything. I probably should change it, that it returns something for me to know that things did go wrong, and it should actually crash or something. Like not crash per se, but the application inside the VM did something weird and should crash. And that's it. It should actually work now, or it will not work, but it should work. It will not work because of these errors, for example. So okay, okay. Why am I not using this one? This one. So because it's actually like clearing the screen, so that's fine. I just comment this out. Get X, that was called arcx, right, or something like that. 3 to 3. arcx, and here's arcx is fine. Okay, so let's do CLS and make and run. Opcode in unused parameter. Why is it unused? I thought I had implemented everything, so why is it unused? That's why you have warnings enabled. I did not implement this. How could I forget about the most important instruction ever? I mean, I have no idea what is this instruction. Sets I to the location of the sprite. Oh, okay, this is font writing. I do need to implement this later. I'm not going to implement it now. What I'm going to do now is I'm going to just do I equals 0. Cool, let's continue. Then I'm going to remove this warning. Okay, 502. Entry handler. Right, because this is a method, so how did you do it? So I think it was something like this. VM dot this. Sorry, is VM actually? I think VM is actually a unique pointer, so I think it should be more like this. No, is it not called VM? What is it called? It's the main loop. Oh, sorry. No, wait. So this is this. I'm just using this here. Okay. I did do something wrong. Should it be like this? Perfect. Sentry. Right. Entry, not sentry. This is usually what I... Entry handler opcode. Let's try it like this. Do I need to do this? Yes, I do need to do this. It's like, I'm not using this frequently enough to not struggle with it. My apologies. 610, there is another error. Here, what do we have here? It's private. Well, it was private. It's not private anymore because I am just moving it to public. It's not done properly anyway, so I don't care too much. As in it properly, there should be thread synchronization. There probably should be like a couple of... Oh yeah, Okay, that's interesting. What you did not see is this. This is WinDBG, which is my just-in-time debugger, which just crashed. So before I debug it, well, this was expected, so I'm not too worried about it. A couple of questions. Could you implement a CHIP-8 VM using single-cycle pipeline architecture? What do you mean by single-cycle / pipeline architecture? I am not familiar with the term. It's probably a term I should be familiar with. I'm not. I'm going to look it up later. I'm going to note your question, basically. So maybe I will be able to answer it later on. Later on as in next stream or like on a vlog. Okay, Vestim actually says how it should be coded, but that's not the case. What keyboard do I have? I have G19. So I'm pretty sure I showed it last time as well. Yeah, this one. Yeah. It's quite useful for me because it has these buttons which are, for example, used for zooming. This is not my keyboard, just saying. It doesn't look even as a keyboard, weird keyboard. Just 2 buttons, I guess, or 3. Okay, yeah, debugging. Let's see what happened. So, GDB, CHIP-8, life of the programmer. Running, and it crashed. Why did you crash? With segmentation fault. So, question number 1 is where did you crash? So, let's write out one instruction from RIP, and it's move AL RDX. IR RDX. RDX is this. And so I guess so it tries to draw. Okay, it tries to draw a pixel in the location it should not draw, which is quite funny because I was pretty sure I did get it correctly. Draw big pixel, okay. Oh, come on. Foxtrot Charlie says the gun had actually 2 buttons and 2 slides. I guess that makes sense. Why? What? How did I fail here? I already have this fixed. Last time somebody after the stream told me that I have like this incorrect. So I did already fix this. W. Okay, what is this again? Set screen buffer is equals to W. This should not crash. This is not correct, but it should not crash. Okay, yeah. Life of a programmer. I'm going to do like add some 0 GDB just to have debugging, basically like full debugging capabilities. And I'm going to run it again with Pong. It crashes, and now I actually do see which line is it and what are the... Oh, this is funny. Why are you being funny to me? As you know, the resolution of this device, is actually smaller. Yeah, it is smaller, so why is the application which I'm running trying to be funny? Well, I guess I should have already included proper checks last time. I don't know why I didn't. Maybe because it was the last function I was writing on the last stream. I was in a hurry. Or because I wanted to get a buffer overflow into a really nice buffer overflow as well into my code. Okay, so if x is lower than 0, or x is larger than larger or equal to 64, or y is lower than 0, or y is larger or equal to 64 to 32, obviously, return don't do anything. You don't have to do anything. Let's run it again. And okay, yeah, that escalated quickly. Not that I didn't expect it, obviously. So this opcode, the one which I did not implement, I am going to treat it like a normal call actually. So this is not the call, this is the call. This, oh no, I know this is not what I'm going to do. Oh yeah, so it is a little different. Probably the PC, which my initial PC was not initialized correctly. What I should add here, sorry, in this warning, obviously, where is this warning? Is actually the, so PC is out of bounds because it ran here, but no, I was in the correct place. Here. I should do this, PC equals dot for x. Okay, and PC. So I actually know where is the problem. Okay, wait, and go at the top of my buffer. So it executes some code, and then it goes here. So what I was thinking initially, and I might be still okay. So EA is end of the Pong code probably. The Pong is actually 246 bytes of size, so it's F6. So no, it's not the end, it's near the end. So I guess I'm going to implement this as this opcode the same way I have implemented the call, which is again probably not okay, but probably no, what I'm going to do, opcode. What's the call opcode again? I'm just going to call that opcode like straight on. Okay. Initially I thought I was actually like, PC went to some area of memory which is not initialized, and that's why they're all zeros, and that's why this handler was executed, but it might be actually a legitimate call. I guess I should also look here. Oh no, it's probably not a legitimate call. Probably just I made a mistake in some other place. Still, let's implement it this way and see what happens. Well, nothing happens. I'm going to try to press some stuff, which is bad. But I guess debugging this VM is going to be the topic of the next live stream, given that I'm already 10 minutes past. So let's leave it here. I'm going to upload the code. If you want to have a go at the debugging, then try it. Otherwise, I'm going to probably try to debug it off screen to have it ready and showcase what was the problem on the next live stream. There's a good question. Do I plan to implement a debugger for CHIP-8? I don't plan for it, but that's actually an interesting idea. I'm going to ask Foxtrot Charlie to note it as an idea for the next live stream, or like some live stream. Okay, let's go through the questions now. Again, I'm going to upload this code soon, and we're going to debug it next time to make sure that it's working. Implementation is basically finished, now only debugging is left. At least I think it's finished, unless something apart from sound, but I don't care about the sound and the fonts, but and I might care about the fonts at some point. So let's go through the questions. To clarify my question, would the implementation of how a processor handles instructions matter in a VM? Does it make a difference if you would simulate instruction level parallelism? It's a good question, actually. It should not matter. That's the answer. Now, whether it matters or not is a totally different thing. I guess it depends on the given architecture and how much programmers that used to program for that architecture relied on how the instructions are actually decoded and encoded. in this case, I don't believe that would make any, it would matter too much on like what level would you emulate it. That being said, on some other platforms it might. So I guess if the question is, would it matter or would it make a difference? Not for this architecture, that's what I think at least. That being said, if I would add some kind of parallelism, it might... So it's like this. For example, the way you did delays on 8-bit computers, old 8, I'm not talking about CHIP-8, but on 8-bit computers, was doing a busy loop. So you did a busy loop for like 1000 iterations, and you knew that like 1000 iterations about like, I don't know, 5 milliseconds or something, or like actually half a second closer to that. So if you'd suddenly add some more interesting pipeline, which was not actually implemented in that computer, and that pipeline would do, for example, out of order execution or execute a couple of instructions in the same cycle, then you suddenly break the cycle compatibility. So in that case, it might matter. I'm not sure if I'm actually going like knocking at the right door with the answer, but yeah, again, I don't think it would matter in CHIP-8. It might matter on real emulators of some other architectures. Redraw screen has a typo. Redraw screen. If redraw screen has a typo, it does have a typo. It has quite a lot of typos, actually. Thank you very much. Let's see if this was actually the bug. David S. was the person who did notice this typo. Well done, well done. Yes, it did fix something. At least something is drawn on the screen. Sorry, here was the typo. And here is... something is drawn on the screen, but something. Can I do something with it? No, I cannot. So this is not the only bug, probably. But well done, well spotted. The problem was that I had, if I actually do this, oh, yeah. I had Y's here instead of X's. My mistake, my bad. Okay, so Davides, well done. Is trying to call OOEO, but you do not what? Oh, it's... sorry, let's look at the Pong code again. I guess what Jan is trying to say is that the code which is on this location, sorry, this, is it this location? Yeah, probably. So it's trying to do a call, but you do... does that mean that this is broken? No, this is not true. This is true. So this is trying to do a return, is that what you're saying? And I'm not doing a proper return. Let's quickly check it. So the stack is empty when I return. I'm actually going to do this. When I pop it, no, I think that's correct. And is it really trying to call it? I think it's tried to call A, so this is 8A, this part was wrong. It's actually, yeah, I would have to debug it. I'm not going to do it now. The instruction dispatch will never execute any of these because, oh, I get what you're saying now. Yeah, okay. Nice. Jan, well done. This is a fun bug. So it's not going to ever execute these because this will always match, which is true. So this is easily fixable. So I guess this is like some secret magical values, which is super weird. But okay. I wonder if there are any other instructions like that. So thank you, Jan. Well done, well spotted. Let me try to run. Just changing the order should be enough. It should be fine with just changing the order. Yeah, it somewhat starts to work. At least it's not rendering correctly, but it somewhat works. What's not rendering correctly is actually my screen. For some reason. As you can see, it's somewhat fine. I cannot move, I guess, any... Oh, I can move. Yeah, this is fine. So, something works. The screen is rendering incorrectly. Hey, and I'm even playing with myself. So, thank you, well spotted, Jan, again. Okay. Oh yeah, there was this. Do you plan to implement it? No. From Abhishek, a question: could we also see an example of in-memory decryption of malware in this VM? Probably by modifying the Python code from the first live stream. I'm going to note it as an idea for a live stream. Your instruction dispatch will never execute. Yeah, that's from Jan. I am going to actually give you credit for this somewhere in the code. Sorry, I'm going to change your letters in your name to ASCII. Yeah, I'm giving Jan credit because that was actually a fun bug and well spotted. It would take me a while to figure this out. And I should have noticed it actually looking at the table and making this table, so yeah, my bad. Thanks again for the book again, one of the best I've read. Thank you for your opinion. You probably don't know, but I did publish a book in Polish. It actually even got some awards for the like best IT book of the year or something like that, so I'm quite happy with it. By the way, you mentioned that you plan to make a reverse engineering video course. Any further info about this? No, actually, I mean, yes, I am trying to do it, but I didn't get to doing it yet. So I was thinking first to actually have it around, you know, December available, but it's probably going to be available mid next year. And before that, I'm going to do a short video plus text tutorial commercial series, like premium series, both in English and Polish, about binary files and how to handle them, something for beginners, just to, you know, get a hang of the editor and the process and so on before I jump into making the reverse engineering and assembly 64 tutorials. So yeah, so my reverse engineering tutorials are going to be about x86, 64 bits, like modern stuff basically. And they will include assembly tutorial, so both reverse engineering and assembly together. Screen resolution is important because the screen resolution is hard-coded in the game. I thought my screen resolution was actually correct, as in correct in 64, but that's not the screen resolution. The screen resolution is here. Okay, there's some offset here. There's some offset which I'm missing. Maybe in my draw pixel I have something incorrect, because the ball behaves really well. Here, pixel size. Is this formula correct? I don't think the formula is correct, by the way, which I have here. Yeah, I don't think that my formula here is correct. Or is it? So k should be multiplied by this, and I should add the j. No, maybe it is correct. I'm going to debug later. But the screen resolution is the same. There's an offset here, which makes it not good. Apart from that actually seems playable. At least I can move these brackets. How do I move the other ones? Oh, here. here we go. So yeah, something works. I guess that's it for today. So thank you very much for coming. Mormos, thank you for your donation. That's my second donation today. I think that actually makes like a record to donations. So next week, I guess there won't be too much debugging. I still need to figure out what to do next week. Is either going to be a short continuation of this and then jumping into anti-reverse engineering, or like straight up anti-reverse engineering using virtual machines. So we'll see. If you have any ideas about it, then just let me know. Apart from that, Mormus is going to stream, I guess, in a couple of minutes, and the mission will show up on your screen in about 1 minute. That's it for today. Thank you very much for watching. KrzaQ, thank you for being here and thank you for helping me out. And that's it. Happy hacking. Please try to solve the mission. It's easier than you think, actually. So it's easier than you think, trust me. And good luck, and see you next week or tomorrow if you actually speak Polish, and there is going to be a Polish live stream. Bye bye. I'm going to leave you with a mission and some music.
the whole world at our feet, watching seasons change. Our roads were